Okay, let's have a look at this question now. I know yesterday I said I'd make a video looking at the solution to yesterday's question on the computer, but I was thinking afterwards, no, it's not necessary. I mean, I'm pretty confident the answer's right because we checked it, and it would just become too time consuming to get into a habit of graphing every circle question every time I did one and wasn't 100% sure on it. I'm pretty confident with the answer because we checked it. So I decided, no, I'll move on to the next question today. Keep things moving. Okay, S equals 0 represents the equation of a circle. K is that of a line which intersects. The Urkel proved that S plus lambda K equals 0 for all lambda. Well, I mean, obviously S plus lambda K equals 0 because S and K would have to be 0. I think it's more about the second, the 2 points here that prove that is 0 represents a circle. I don't think you're saying prove that S plus lambda K equals 0 for lambda, an element of R. I think it's more saying prove that, given that it represents a circle, and that the circle passed through the point of intersection of the line and of the circle. Well, let's just first let S be a circle. X squared plus y squared plus ax plus by plus c equals 0, and k equal ax plus by plus c equals 0. So S plus lambda K, that would be x squared plus y squared plus a x plus b. Oh, I forgot my lambda because it's lambda K. So lambda A plus, I'll just write it again. Lambda AX plus B plus lambda BY plus C plus lambda C. And that's equivalent to x squared plus y squared plus alpha x, if you just call that constant alpha, call the next constant beta, and then the last constant here gamma, which is a circle. Okay, so we've proven that it's a circle. It has the same form, the equation. And that the circle passes through the points of intersection of the line and the circle. Okay, so let's say, how will we do this? The circle passes through the point of intersection of the line and the circle. Oh, this circle, not that circle, this circle. The circle we just found. Okay, let xy be on s equals 0 and k equals 0. Or maybe I should call it something like x1, y1, be on s equals 0 and k equals 0. So, in other words, s equals 0 is the circle, k equals 0 is the line of which intersects the circle. It doesn't say if it intersects it once or twice. Once or twice. So x1, y1 is one of these points here. And we have to prove it's on the circle we just found. So if we calculate it, it's s plus lambda k. It just seems pretty obvious, because if you sub x1, y1 into s, you get x1 squared plus y1 squared, etc., etc. And if you sub it into k, you get ax1 plus by1, etc., etc. But we know that this equals 0 and this equals 0, so the total equals 0. So if it's on s and it's on k, then that implies it's on s plus lambda k. Yeah, okay, so that takes care of the first part. Oops. Now, find the equation of the circle C, which contains the point of intersection of that circle and that line, and which has its center on that line. No problem. So, using the result we've just proven, if we take that as S and that as K, then we have the equation x squared plus y squared plus minus 1 plus 2 lambda plus x plus minus 1 minus 2 lambda minus 2 plus 2 lambda equals 0. So we have our, again, just to remind us, we have our circle S, we have K, and then this equation here for any lambda will represent the circles that pass through the intersection point. So it could be like this or whatever. What we need to do is find the value of lambda that will make the circle have its center on this line. Now, actually, I realize very likely my eyes might have switched between the two. I just spot that now. Minus 1 plus 2 lambda minus 1 minus lambda. You see, I was looking at the second equation when I was transcribing. That's going to be a mistake I'm sure people will make here. And minus 2 plus 2 lambda. Yep, let's just double check it. Minus 1 plus 2 lambda, minus 1 minus lambda, minus 2 plus 2 lambda. Okay. The center is going to equal this divided by 2 with the sign changed. So that's going to be 1 minus 2 lambda over 2 and 1 plus lambda over 2. And that needs to be on 2x minus 2y minus 9 equals 0. It's nice that they put the 2's in there. So if I sub that in, I'll get 1 minus 2 lambda minus 1 minus lambda minus 9 equals 0. So 1 and minus 1 cancel, and I'll get minus 9 is equal to 3 lambda. Lambda is equal to minus 3. Sub that in. I get x squared plus y squared minus 1 minus 7x minus 1 minus minus 3, that's 2y, minus 2 minus 6 is minus 8 equals 0. Okay, the circle C intersects the y-axis at A and B. Find the distance. Okay, let's see. Find where it crosses A and B, basically. Oh, it's two quadratics, fine. Okay, so if we let x equals 0, we get y squared plus 2y minus 8 equals 0. Oh, it's only intersecting the y-axis, okay, at A and B, okay. 4 and 2. y plus 4, y minus 2. So that's going to be at 2 and minus 4. So obviously the distance there is 6. Okay, not a bad question. I kind of feel like this one I'll want to graph, because I'm not sure if there's any easy way to check if we got the answer right. I mean, it's nice that the answer worked out as 6 at the end here. Yeah. Yeah, maybe this one I'll graph tomorrow, because what I can do is I can graph this, find the equation of the circle C which contains the point of intersection and that line, and I can graph this, and I can graph this. So what I'm expecting is something like this, like what I just drew there. Let's just draw it again. A circle S, a line K, circle S, a line K, and then another circle that passes through these 2 points but has its center on this line. So like, let's just imagine that the circle is some bigger circle here that passes through these 2 points, and its center is perhaps on this other line here or whatever. And then I think from a graph we can kind of tell if it's right. So maybe I'll graph this one tomorrow, because I don't have any nice easy way I can think of off the top of my head to verify if this answer is right, other than going to the trouble of solving points of intersection. So yeah, maybe I will. Okay. Yeah, not a bad question. I've kind of been going through it slowly, dilly-dallying and talking, and I'm still only at 12 minutes. So that's pretty decent. I think I've answered everything. Yeah, okay. Let's leave it there.